Why does a scale move when you step on it if you are made almost entirely of nothing? You feel the solid press of a chair against your legs or the weight of a glass of water. Yet the tangible world is a sophisticated illusion. We are taught that atoms are microscopic bricks building our bones and brains. If you zoomed past your skin and into the heart of a single atom, you would find a reality that functions like a magic trick. You are not solid, you are a yawning void where almost every pound of your body weight originates from a vacuum. The scale of this internal emptiness is difficult to fathom. Imagine a single atom enlarged to the size of a massive football stadium. The nucleus, the center where the supposed stuff lives, would be no larger than a marble on the 50-yard line. Electrons would resemble tiny gnats buzzing around the highest bleachers. Everything else, the seats, the field, and the air in the stands, is empty space. If you squeeze the void out of every human on Earth, the entire race would fit inside a single sugar cube. That cube, however, would weigh 5 billion tons. Common sense suggests this weight comes from the particles themselves, those marbles at the stadium center. In 1964, Murray Gell-Mann at the California Institute of Technology proposed that those marbles were composed of smaller entities called quarks. We eventually found them, but they presented a problem for our understanding of reality. When scientists measured the mass of these quarks, the numbers failed to add up. The 3 quarks inside a proton account for only 1% of its total weight. The other 99% of your mass is not made of particles. It is the binding energy of a ghost-like force holding you together. When you stand on a scale, you are not measuring physical matter. You are measuring the intense energy required to keep your atoms from flying apart. According to Albert Einstein's E equals mc2, energy and mass are 2 sides of the same coin. In the subatomic world, energy literally becomes weight. The strong nuclear force gluing your quarks together is so powerful that the effort of that glue manifests as physical heaviness. You are a walking collection of energy fields that have fooled themselves into thinking they are solid objects. Every object you touch, from a cold metal door handle to the soft fur of a pet, is a shimmering cloud of energy vibrating in a vacuum. We perceive ourselves as solid because the forces between these particles push back when we try to move through them. It is like pushing 2 powerful magnets together. They never actually touch, but the invisible field creates a hard barrier. You have never truly touched anything. You have only felt the electric repulsion of your atoms meeting the atoms of the world. This discovery overturned centuries of belief that the universe was a machine made of hard marbles. As we look deeper, the marbles disappeared. At the bottom of reality, there is no stuff left, only math fields and energy. Researchers at the Stanford Linear Accelerator Center proved this in the late 60s by firing electrons at protons. They watched them bounce off tiny points of energy like bullets hitting invisible targets. They weren't hitting walls, they were hitting knots of concentrated force. If this binding energy vanished, you would not just crumble, you would cease to be. The particles making you up would have no reason to stay near one another, and the you occupying space would evaporate into a cloud of weightless dust. We exist in a delicate balance where the invisible is far more important than the visible. The mass giving you presence in the world is a byproduct of a cosmic struggle happening trillions of times a second inside every cell. You are a living testament to the fact that energy can take a physical form. This brings us to a terrifying and beautiful realization. If most of our mass is energy, the universe is far less crowded than it looks. We see stars, planets, and mountains as objects, but we are actually witnessing activity. Weight is not a property of things. It is a property of processes. The reliable world is a frantic dance of invisible forces occurring at unimaginable speeds. We are not just residents of the universe. We are a specific way that the universe's energy has decided to bundle itself up. Where did the original tiny bit of mass, that 1% belonging to the quarks, come from in the first place? For decades, this was the ultimate missing link in physics. Scientists knew something had to give those particles their starting weight, or the energy would have nothing to latch onto. Without that seed of mass, the universe would have no gravity. No stars would form, and light would be the only thing that existed. In 2012, researchers at the Large Hadron Collider finally confirmed the existence of a field that permeates every inch of the cosmos. It acts like a thick syrup that slows particles down and gives them weight. This mechanism transforms invisible energy into the physical reality you see in the mirror. You are a walking explosion held in place by a ghost, a collection of nothingness that has gained the power to feel, to move, and to wonder why it exists. The specific way this ghost-like field interacts with the void inside you is the only reason you have a body to call your own. Does the number flashing back from a bathroom scale represent an undeniable truth? You feel the weight of bone, muscle, and cellular water, but zooming past the skin and atoms into the protons reveals a mathematical mystery that baffled the 20th century. In 1964, California Institute of Technology physicist Murray Gell-Mann proposed that protons were not solid blocks. He suggested they consisted of three smaller particles called quarks. For decades, the scientific community assumed that adding the weight of these three quarks would equal the total weight of the proton. It sounds like basic addition. If a bag contains 3 bricks, the bag should weigh as much as those bricks. However, when the math was finally calculated, the results were nonsensical. The 3 quarks only accounted for 1% of the proton's total mass. The other 99% was missing. Imagine buying a heavy suitcase that feels packed with lead, only to open it and find 3 paperclips rattling inside. This is the reality of your body at the subatomic level. In 2008, an international team of physicists known as the BMW collaboration used powerful supercomputers to solve this discrepancy. They published their findings in the journal Science, confirming a reality that sounds like science fiction. The weight you feel when lifting your arm or carrying groceries does not come from physical stuff. It originates from the violent energy required to keep those 3 tiny quarks from flying apart. This is the strong nuclear force. As the most powerful interaction in the known universe, it is so intense that the energy itself takes on the properties of physical weight. To understand how energy becomes weight, you must look at how these particles behave. Quarks are restless, zipping around inside the proton at near light speeds while trapped in a space so small it defies human processing. They are held together by messenger particles called gluons, which act like a cosmic glue. This is not a static connection like a drop of adhesive on a tabletop. It is a frantic high-speed tug-of-war. The gluons constantly pop in and out of existence, snapping between the quarks with incredible tension. In physics, energy and mass are 2 sides of the same coin. Because these bonds are incredibly strong, the energy stored within them manifests as the heaviness of the proton. You are not made of heavy pieces. You are made of light pieces held together by a heavy struggle. Consider a common household spring. When the spring sits on a table, it has a certain weight. If you pull that spring apart with all your might, you pour physical energy into the tension of the metal. If you could lock that tension in place, the spring would technically be heavier than it was before you pulled it. In our everyday world, that change is so microscopic we could never measure it. Inside your atoms, however, that tension is everything. The strong force is so overwhelming that it dwarfs the weight of the particles it holds. According to the 2008 study, turning off this force would cause you to instantly lose 99% of your body mass. You would not just be thin. You would essentially cease to be a physical object in the way we understand it. This discovery changed how we view the vacuum of space inside an atom. For a long time, we thought of the space between particles as empty nothingness. The work of Frank Wilczek and David Gross, who won the Nobel Prize in 2004, showed that this nothing is actually a roiling sea of activity. They discovered a property called asymptotic freedom, which describes why quarks stay so tightly bound. When quarks are close together, they barely feel each other. The moment they pull apart, the force between them grows stronger, like a rubber band being stretched to its limit. This constant stretching and snapping creates the mass that registers on your bathroom scale. Your weight is the signature of a storm happening inside your cells trillions of times every second. But here is where it gets strange. If almost all of our mass comes from this invisible energy, what about the remaining 1%? That tiny sliver of matter, the quarks and the electrons, does have its own intrinsic mass, but even that has a surprising origin. In the 1960s, Peter Higgs proposed that these particles only have weight because they swim through an invisible field permeating the entire universe. It is called the Higgs field. Without it, the building blocks of your body would have no weight and would zip through the universe at the speed of light, unable to form an atom, a molecule, or a human being. We spent decades and billions of dollars building the Large Hadron Collider to prove this field existed, finally confirming it in 2012. We are left with a two-part reality. 1% of your weight comes from particles interacting with an invisible cosmic molasses, and the other 99% comes from the raw, vibrating energy of a nuclear tug-of-war. The solidity you feel when you touch a table or a wall is an illusion. You are feeling the resistance of forces, not the presence of solid objects. Scientists still cannot explain why these forces are tuned exactly the way they are. If the strong force were only slightly weaker, the energy would not be enough to hold atoms together. The universe would be a cold, dark soup of stray particles. We exist because of the precise tension of a hidden machine. This matters for our understanding of the entire cosmos because mass is just energy in disguise. It changes how we look at the largest structures in the universe. We can now calculate the energy contained within a single human body, and the numbers are staggering. If you could release the binding energy holding your quarks together, you would not just disappear. You would trigger an explosion larger than the most powerful nuclear weapons ever detonated. You are a walking reservoir of immense power, kept under lock and key by the laws of physics. This realization leads to a deeper, more unsettling question. If we are made of energy and empty space, why does the world feel so incredibly solid? Why does a lead weight feel heavy and a feather feel light if they are both just different concentrations of the same invisible force? The answer lies in the way these forces interact with gravity, the weakest but most persistent force in nature. Gravity does not care if the mass it pulls on comes from a solid particle or a vibrating field of energy. It pulls on the total sum of that tension. The heaviness you feel in your limbs at the end of a long day is gravity reaching out and tugging on the invisible energy trapped inside your atoms. It forces us to ask what else we might be missing. If 99% of our own weight was a mystery until recently, what other invisible components are hidden in the fabric of reality? We have mapped the stars and peered into the depths of the ocean, but we are only just beginning to understand the ghost-like mechanics that allow us to stand upright. Scientists are now looking beyond the proton to the dark corners of the galaxy, wondering if the same principles of mass from nothing could explain the missing pieces of the universe itself. If energy can pretend to be matter inside your body, it might be doing the same thing on a scale we cannot even imagine. Who or what is really pulling the strings of the cosmic scale? Why does a human body feel heavy when you step on a scale? We usually treat Einstein's E=mc² as a manual for destruction, a way to explain the blinding flash of a nuclear weapon or the relentless heat of the sun. In those explosions, a sliver of solid matter vanishes and transforms into a terrifying amount of energy. But inside your own cells, at this very moment, that process is running in reverse. Energy is not being released. It is being trapped and squeezed so tightly that it begins to act like a solid object. This is the secret of your weight. The energy itself is so dense that it creates the physical sensation of mass. If you could somehow reach inside your atoms and turn off the forces holding them together, your physical body would not just crumble. It would vanish into a burst of light and heat. For a long time, the center of an atom remained a total mystery. In 1911, at the University of Manchester, Ernest Rutherford was firing tiny particles at a thin sheet of gold foil. He expected them to pass straight through like bullets through tissue paper. Instead, some of them bounced straight back at him. He famously said it was as if you had fired a 15-inch shell at a piece of tissue paper and it came back and hit you. This led him to realize that the nucleus was incredibly small and incredibly dense. But even Rutherford couldn't see the real secret hiding inside that density. He had found the container, but he hadn't yet discovered the source of the weight. By 1932, James Chadwick at the Cavendish Laboratory discovered the neutron, and the picture seemed complete. We had protons and neutrons sitting in the center, and electrons buzzing around the outside. It was a neat, tidy solar system model that we still teach in schools today. But there was a massive problem with the math. When scientists weighed the individual particles that make up a proton, the numbers didn't add up. A proton is made of 3 smaller particles called quarks. However, if you add up the mass of those 3 quarks, they only account for about 1% of the proton's total weight. It was like buying a bag of flour that weighs 10 pounds, only to find that the flour inside only weighs a few ounces. This mystery haunted physics for decades until 1964, when Murray Gell-Mann at Caltech and George Zweig at CERN independently proposed the existence of these quarks. But it wasn't until the late 1960s at the Stanford Linear Accelerator Center that researchers actually proved they were there. Jerome Friedman, Henry Kendall, and Richard Taylor used a massive electron beam to peek inside the proton. They found 3 distinct points of matter. But again, those points were far too light to explain why a human being feels heavy. They realized that the missing 99% of your mass wasn't a physical thing at all. It was the sheer intensity of the glue holding those pieces together. Think of a heavy industrial steel spring. If the spring is just sitting on a table, it has a certain weight. But if you use a massive piston to compress that spring until it is only an inch tall, you are pumping energy into it. According to Einstein's rules, that added energy actually increases the weight of the spring by a tiny, microscopic amount inside your atoms. The springs are the strong nuclear force. This force is so powerful that the energy stored within it is massive enough to become the very substance of your body. In 1973, David Politzer, David Gross, and Frank Wilczek published the work that finally explained this glue. They showed that the closer quarks get to each other, the less they feel the force, but the moment they try to pull apart, the force becomes insurmountable. This creates a chaotic, vibrating sea of energy inside every one of your cells. Scientists call this the quark-gluon sea. It is a storm of particles popping in and out of existence, held together by the strong nuclear force. The energy of this storm is what gives you substance. In 2004, the Nobel Prize in Physics was awarded to Politzer, Gross, and Wilczek because they proved that your mass is essentially a localized pocket of intense energy. You are not a collection of solid marbles. You are a collection of incredibly energetic vibrations that refuse to let go of each other. This energy is so concentrated that it resists being moved, which is exactly how we define mass in a physics lab. But this raises a deeper question. If we are held together by this overwhelming force, why don't we feel like a vibrating storm? To our senses, a wooden table feels cold and still. A glass of water feels heavy and calm. This is because the scale of this activity is so small that it averages out into the sensation of solidity. The 1990 Nobel Prize given to the Stanford team confirmed that even though the inside of a proton is a violent, high-speed environment, the boundary of the proton remains stable. It is a perfect cage for a wild animal. The animal is the energy, and the cage is the strong force. Together, they create the illusion of a solid object that you can touch and feel. Even the small amount of mass that isn't energy, that final 1% comes from a strange source. In 1964, Peter Higgs proposed that particles only have weight because they are dragging through an invisible field that permeates the entire universe. It is like trying to run through a pool of thick molasses. The harder it is for the particle to move through the field, the heavier it feels to us. This was finally confirmed in 2012 at the Large Hadron Collider. Even the solid parts of you are just interactions with an invisible field. Between the energy of the strong force and the drag of the Higgs field, there is almost nothing solid left in the human body at all. This realization changes how we define the word material. We think of material as something we can grab, but science shows that material is just a specific state of trapped energy. The atoms in your hand and the atoms in the screen you are holding are just different patterns of this trapped force. It is a constant, invisible tension that never rests. If the strong nuclear force were to weaken by even a fraction of a percent, the energy would win, the cages would break, and the entire visible universe would dissolve into a featureless soup of radiation. We exist only because the energy is perfectly contained. So the next time you feel the weight of your own body after a long day, remember that you aren't feeling the weight of matter. You are feeling the weight of a cosmic struggle. You are a walking, talking evidence of Einstein's most famous theory. A living container for energy that is trying to fly apart at the speed of light but is being held in place by the strongest force in nature. It makes you wonder, if 99% of our mass is just energy acting like matter, what happens to that energy when the atoms themselves are pushed to their absolute limit? Consider the implications, because the next part is the reason the universe even exists in the first place. What happens when that energy is finally let loose? Why does everything you have ever touched feel solid despite being built on a paradox? We often imagine the universe as a collection of tiny marbles stacked together to form a person or a planet. The deeper physicists look, however, the more those marbles seem to vanish. In 1964, Murray Gell-Mann at the California Institute of Technology proposed that protons and neutrons were actually composed of even smaller particles he called quarks. These quarks should provide your weight. Yet when scientists measured the mass of these quarks, they found the 3 particles inside a proton only account for 1% of its total mass. The other 99% is not physical stuff. It is a ghost-like force holding those pieces together. This force is the strongest thing in the known universe. Scientists named the particles that carry this force gluons because they act like a cosmic glue. Unlike the quarks they hold together, gluons have no mass, they weigh 0. They are pieces of nothing. In the world of the very small, the rules of our everyday lives stop working. We expect a box of heavy bricks to weigh more than the glue holding the box together. But in your body, the opposite is true. You are a box filled with weightless glue moving so fast that it creates the illusion of weight. To understand how nothing creates something, we must look at the violence happening inside your cells. Within every single proton in your body, quarks and gluons scream around at nearly the speed of light. They are trapped in a space so small it defies imagination. Because they move with such incredible energy, they gain mass through the logic of Einstein's physics. The energy itself becomes the weight you feel when you step on a scale. If you could somehow freeze the particles inside you for just a second, you would lose 99% of your mass instantly. You would become a thin, ghostly mist of quarks with almost no physical presence. But you cannot stop them. In 1973, David Gross and Frank Wilczek discovered a property of this force called asymptotic freedom, a discovery that won them the Nobel Prize. Most forces in nature get weaker as things move apart. Think of 2 magnets. The further you pull them away from each other, the less they tug. The strong nuclear force does the opposite. When quarks are close together, they barely feel the force at all, wandering around like kids in a playground. But the moment you try to pull a quark away from its partners, the force snaps tight like a cosmic rubber band that gets stronger the further you stretch it. This leads to a reality of physics called color confinement. You can never see a single quark by itself. If you were to take a proton and try to pull one of its quarks out with infinite strength, you would fail as you pull harder. You pour massive amounts of energy into that rubber band of force. Eventually, you put so much energy into the gap that the energy itself snaps. It does not just break. According to the laws of the universe, that raw energy transforms into new matter. Instead of pulling one quark out, you create two new quarks. The universe would rather create matter out of thin air than allow a single quark to exist in isolation. This cosmic glue creates a pressure inside the proton higher than anything else ever measured. In 2018, researchers at the Thomas Jefferson National Accelerator Facility calculated this pressure at 10 to the power of 35 pascals. That is a 1 followed by 35 zeros. To put that in perspective, that is 10 times the pressure found inside the core of a neutron star, the densest object in the universe. Your body is held together by a force so intense it makes the center of the sun look like a vacuum. Every second of your life, this invisible tension keeps you from flying apart into a cloud of energy. Scientists still struggle to explain why this specific balance exists. If the strong nuclear force were a tiny bit weaker, protons would fall apart and atoms would never have formed after the Big Bang. There would be no carbon, no oxygen, and no stars. The universe would be a cold soup of stray particles drifting through the dark. On the other hand, if the force were slightly stronger, two protons would fuse together so easily that all the hydrogen in the early universe would have burned up instantly. There would be no water and no long-lived stars like our sun. We exist in a razor-thin margin where nothing is just strong enough to become something. This brings us to a mystery that keeps physicists awake at night. If our mass is mostly energy, and that energy results from particles moving around, what happens to that energy over a long enough timeline? We know the universe is expanding and that forces can change. Some theories suggest that in the distant future, the vacuum of space could undergo a change in its energy state. If the nature of this glue ever shifted by a fraction of a percent, the solid world would cease to be solid. The chair you are sitting on, the air you are breathing, and the bones in your body would lose their ability to hold mass. We like to think of ourselves as solid beings living in a solid world. We build houses out of stone and ships out of steel. We trust the ground beneath our feet because it feels heavy and permanent. But the truth is that the steel, the stone, and your own skin are all temporary expressions of a frantic, high-energy dance. You are not a collection of solid objects. You are a collection of echoes. You are the sound of a trillion tiny bells ringing so fast they feel like a solid wall. The weight you carry is not the weight of atoms, but the weight of the struggle to keep those atoms together. But that is not even the strangest part of the story. If almost all of your mass comes from the energy of these weightless gluons, it raises a haunting question about the nature of existence. If 99% of you is energy masquerading as matter, what is the other 1%? We know the quarks have a tiny bit of mass of their own, but where does that come from? To find that answer, we must look past the glue and toward a field of invisible energy that blankets the entire universe. It is a field that was only a theory for 50 years, until a giant machine in Switzerland finally proved that the final piece of the puzzle is even more ghost-like than the rest. How can the chair beneath you or the cold glass in your hand be anything other than a solid block of matter? You have spent your entire life believing in a world built from physical building blocks, like microscopic marbles stacked tightly together. The reality uncovered by Murray Gell-Mann and the teams at the Stanford Linear Accelerator Center tells a different story. When you strip away the layers of the atom, you do not find more solid objects. You find a ghost-like dance of energy. The weight you feel when you pick up a heavy suitcase is not the weight of stuff. It is the weight of a storm. You are a collection of vibrations and intense fields of force. This realization changes our definition of solid forever. If you were to remove all that empty space and all that trapped energy from your body, the physical matter left behind would be smaller than a single grain of sand. Yet that tiny speck would still weigh exactly what you do now. Every time you step on a bathroom scale, you are not measuring your mass in the traditional sense. You are measuring the trapped kinetic energy of the universe. The number that flashes back at you is a report on the sheer intensity of the forces holding your atoms together. It is a measurement of a cosmic tension that never rests. We often imagine that we are separate from the world around us. But this discovery proves that we are made of the same fundamental nothingness as the stars and the deep ocean. The strong nuclear force that gives you your weight is the same force that powers the sun. In 1973, Frank Wilczek and David Gross showed that this force actually gets stronger the further these tiny particles try to pull apart. It is as if you are held together by trillions of invisible rubber bands that never snap. This is why you feel solid. You are a localized knot of energy so dense and so fast that it creates the illusion of a permanent physical object. Scientists at the European Organization for Nuclear Research, or CERN, spend their days smashing these particles together to see what falls out. They have found that the world is far less like a machine and far more like a symphony. If you could zoom in far enough, you would not see little balls of matter spinning in circles. You would see fields of energy rippling like the surface of a pond after a heavy rain. The mass of your body is the result of these ripples interacting with one another. We are made of the same stuff as light, just packaged in a way that feels heavy to the touch. It is strange to think that if these forces shifted by even a tiny fraction, you would simply dissolve. The you that you see in the mirror only exists because the vacuum of space is filled with a specific amount of tension. Without that 99% of nothing providing your mass, the atoms in your body would have no way to stay clumped together. You would have no weight, no form, and no way to interact with the world. We owe our entire physical existence to the fact that empty space is not actually empty. It is a reservoir of power that gives shape to everything we have ever known. This changes how you might look at the objects in your home. That heavy wooden table or the steel frame of a car is a clever arrangement of energy. When you push against a wall, you aren't feeling two solid things hitting each other. You are feeling the electromagnetic and nuclear forces of the wall pushing back against the forces in your own hand. It is a battle of fields. The world is a collection of events happening so fast and so consistently that they appear to be solid. We are living inside a beautiful, high-speed illusion. You can see this truth in the way the world functions on a massive scale. The reason planets have gravity and stars can burn for billions of years is tied directly to this trapped energy. If mass were just a property of little physical marbles, the universe would be a cold, static place instead because mass is energy. The universe is dynamic and alive. Every gram of your body is a testament to the sheer activity occurring at the smallest possible level. You are a walking explosion that has been perfectly contained by the laws of physics. Take a moment to look at your own hand. It looks solid, it feels warm, and it has a specific weight. But you now know that the weight you feel is the result of particles called quarks moving at near-light speeds, trapped inside tiny bubbles of force. You are feeling the legacy of the Big Bang held in a stable form. The physical world is not a stage that we walk upon. It is a shimmering, vibrating web that we are part of. There is no us in the universe. There is only the energy, and the many different ways it chooses to manifest. If we are made of nothing but energy, it suggests that the reality we touch every day is just the surface of something much deeper. We spend our lives worried about physical things like our weight, our possessions, and the walls around us without realizing that these things are as fleeting as a note played on a violin. They exist because of a specific vibration. This perspective does not make the world less real, but it does make it feel more miraculous. You are a ghost made of light and motion, held together by a force so strong it defines the very fabric of space. Next time you feel the solid press of a chair against your legs, remember the storm raging inside your atoms. Remember that you are a measurement of the universe's hidden power. You are not a heavy object moving through a vacuum. You are the vacuum itself, vibrating with such intensity that you became solid enough to wonder why. The world is not made of pieces. It is made of processes. And you are the most complex process the universe has ever designed. Subscribe a new breakdown like this every day.